So this is the worksheet that I sent out that goes from 1 to 200. And if you filled it out, these would be all of the numbers that you should have been getting. And it's really hard looking at the worksheet this way. So I laid it out just in a different way. So I grouped it between the primes between 1 and 20, 21 and 40, all the way down to 181 to 200 to make it easier to look at the groupings of primes. Remember that last we talked about twin primes. Who remembers what a twin prime is?
I think it was two prime numbers that had a difference of 2.
So give me an example. That's correct.
3 and 5 would be.
3 and 5. Julia, call on someone to give me another pair of twins.
7 and 11.
7 and 11. Are they twin? Twins differ by 2. So 3 and 5 are twins.
Oh, yeah. Then 11 and 13.
Right. So there's 11 and 13. Everybody are 17 and 19
Yes.
twins.
Yes.
Yes.
Yes. But Sebastian, guess what? 7 and 11 are cousins. These are cousin primes. So are 13 and 17 cousin primes.
So cousin primes have a difference of 4?
Absolutely. Good thinking. Anybody see any other cousins on this page?
37 and 41.
30. Good thinking. Anybody see another pair of cousins?
43 and 47?
All right. Excellent, Franklin. Someone other than Franklin, give me another pair of cousins.
103 and 107.
We had 103 and 107 are cousins.
67 and 71.
6, 7, and 71. Very nice.
109 and 113.
109 and 113. Wow. There's lots of cousins on here. So this is something that could be fun to play with.
193.
131.
127 and 131.
193 and 197.
180. What? One. Say it again.
193 and 197.
Beautiful. Excellent. Look at that. 197, 199 are twins, and 191 and 193 are twins.
163 and 167.
Woo, fantastic. All right. So mathematicians just define, they just say, okay, if you differ by 2, we're going to call them twins. If they differ by 4, we'll call them cousins. You can make up your own rule. You might want to say second cousins differ by 6 and third cousins differ by 8 and see if there are any of those and just play around with it. That's what mathematicians do. They just play around with these kinds of ideas, and that's how they build mathematical ideas. And that's mathematical thinking. I'm going to stop sharing. All right. Any questions or comments? Anybody would like to make any suggestions? Say anything about twins, cousins, and primes? Franklin, what's your reaction to all that stuff?
I think it's kind of cool. how prime numbers have like relatives.
Yeah. Maya, do you have any reactions to all of this?
I think it's pretty cool and fun.
Okay. Arlo?
It was kind of a little hard, actually. Although it made it easier, I just didn't want to go around Xing out all of the non-prime numbers.
Xing out the non-primes is a way to find the primes. Well, what made it hard to find them? Sasha?
Yeah, I thought it was a little hard to find the multiples of 7, though, because there wasn't a special pattern you could use or a special strategy you could use to find multiples of 7.
Correct. How about for multiples of 13? Was there a special pattern for that?
Well, I couldn't find any.
There isn't. Unfortunately, it's just hard work. And in 2018, the math societies in the world gave $100,000 prize to someone who was able to find the next prime number, because they used a huge supercomputer and they just kept dividing into the next number until they found the next prime number. If you're interested, look it up on, go to the website in your search and type in prime numbers and see some of the fascinating stuff about it. So I'd like to do a couple of more problems with prime numbers today that'll introduce a couple of more fun ideas for you. Maya, can you read the problem out loud to everyone? And then we'll go into our breakout groups for 20 minutes